Hello everyone, this is the first installment of our workshop in which we're going to go through the basics of the language. I'm not going to go through the whole why Scala and such because this is not important at this moment. And the first thing we're going to do is start with the Scala worksheet. This will help us very fast evaluate whatever we're writing. So as you can see, it has a run button, so whatever you're writing here, it will be evaluated here. It will be just like using the console. So let's start with our first statement, just like in Java, print line, hello mortals. So you see, this wasn't so bad, and now IntelliJ, after a long battle, will print me hello mortals. What shall we start with? We will start with simple expressions. Almost everything in Scala is an expression, so what is the simplest thing we can write is 1 plus 1, and this can be very easily evaluated. It's just an expression, and let's see what it says. This res1 is an auto-generated variable name by the compiler, and it will hold the value of the expression that was evaluated, which is 2, and it will have the type inferred based on what the resulting type of the expression it is. Most of the time the types can be inferred automatically. So this is the basic expression there is. A block of code also is evaluated, and you can have a block of code just simple between parentheses, accolades, and the interesting part is when you have a block of code, the last expression that is evaluated in that block of code will give its type. So if I will have hello mortals, and then I will have 2 plus 2 at the end, and I run this. Also for this block of code, the compiler would automatically assign a variable called res2, and the value of this block of code will be 4 because it's the value of the last expression here, the last line, right? And it will be an integer, class int. Okay, we have now variables, right? We have multiple types of variables, and they can be immutables, just like you would have in Java a final variable, like final string name equals Dave. That's what you would write in Java, right? And how does this go in Scala? Well, you have to use this identifier called val, and this tells it, okay, it's an immutable value, what's coming next. You start with the name of the variable, you start with an column, the type, and it says it equals Dave. Just like any final variable, you have to give it a value once you declare it, otherwise it will complain. So if I wouldn't write that one, and I'll say, okay, I want to compile this, it should now complain, right? Error. Only classes can have declared but undefined members, so you do have to give it a value here. But once you give them a value, you cannot change that one. So if I would want to say name equals Claudia, now this will complain. And what does it complain to? Reassignment to val. So you're not allowed to reassign anything. Now, like I said before on the expression, you don't have to specify the type of the value. So you can say val surname equals really, and now this one will know it's a string because this expression evaluates to a string, so it will know already this is Java string. You can see here that it says just string here and then Java string on the other part. Actually, this string is the Scala string, and if I go here, it's defined as a type, but it's actually the same type as Java string. So it's just a syntactic sugar, so you don't have to import everything and so on. And they're compatible because basically they're the same thing. And now we have the mutable variables. And what does mutable mean? Means you can change the binding, so you can give it another value. And that one starts with var, and again, mutable one, and we say it's an int and has value 2. We can print it. Oh, actually, we don't need to print it. We can just say here, evaluate this worksheet. And we want to say mutable 1 is an integer, and the value that it has, it's 2. Okay, I can say mutable 1 is 3 now. So I give it another value, and now it should not complain because it's a var. We have a lot of basic types like char and doubles and ints, just like in Java. The actual int is it's defined by Scala. So we have bytes, we have shorts, chars, ints, longs, floats, and doubles, just like in Java. For example, a character will be the type char, and how you write characters is between single quotes. And if you like a long string, and if you would like to write it on multiple lines, we can use the triple quote notation. So triple quotes and say a very long string that spans multiple lines. As you can see, the IDE added this begins of the lines whenever I pressed enters, and then in the end it says strip margin. You can have it without that one, just like that. You don't have to strip the margin. It's the same thing, but it looks prettier because then you see every line separate. And this is kind of it for the basics of how you're gonna declare your variables. So remember, val, as in here, is for immutable ones, so final variables, and var is for mutable ones. So now let's start another worksheet, and this will be functions. And now let's talk about functions and also methods. Most of the time the difference between functions and methods is not so obvious, so sometimes you use them interchangeably, but sometimes you will see a very big difference between them. But let's start with it as they would be the same, right? So most of the times we define them like we start with the def. This is a predefined keyword that says define me this method, and we say 3 multiplied by, and I have the parentheses, and now I have the list of parameters. I'm gonna say it's an integer, and I'm gonna say okay, it returns an int, and the body of the function will be in a coded block, and I'm gonna say it's 3 multiplied by x. So what does this mean? As you can see, in Java you would start something like function 3 multiplied by int x, and then calculados, and then you will say return 3 times x. Well, in here you don't need to write the return statement, because the return will be whatever is the last expression that is evaluated. Remember that the arguments are declined the other way around, so first you will say the name of the argument and then the type. Then also in here you'll probably need to say also that it returns an int in front. In here you say it returns an int at the end. Then you have to say, you have to specify equals, and then the rest it's kind of almost the same, right? So that will be the Java way. Okay, and let's run this one and see what it gives us. Okay, it tells us that I have a function called 3 multiplied by 3, which accepts an argument of integer and it returns an int. Okay, so this is the basic declaration, and you can easily call it by 3 multiplied by 2, or you can assign it to a variable, either var or a val, and say result is 3 multiplied by 45. I managed to type this, and what this is going to be, right? I have a automatic variable here that will say, okay, it's an int and it holds the value 6 because it's 2 multiplied by 3, and then 3 multiplied by 45 is 135. So in here to this variable I said, okay, evaluate me this method call here. Now the question is, what is compulsory, what is not? How can I define it just in one-liner or something? Can some things go? And the answer is yes. So the def unfortunately cannot go, but you can go with 3 multiplied with, this is, I give it a different name, and x has int. And the thing that cannot go is that on the arguments you have to specify the types, but you don't have to specify what the return type is because it can be inferred, right? You can say equals, and then you can say 3 times x, and that makes it shorter. So you don't have to put the acolados necessarily if it's just one line or one block of code. If you have multiple lines and you want to treat them all in the same function body, then you'll probably need acolados. Okay. How would one look like just saying without any arguments? If I don't have any arguments, I can just say this and then equals to hello world, but I can also just leave the acolados. It also is a very valid definition. What happens if I don't put this equals here? Well, what will happen is that your method won't return anything. Actually, it will return something called an unit. So if I say define saying hello, and I would say print line inside the method, and then now I would like to return a string, hi there. What do you think will happen if I'm gonna run this? As you can see, just saying, it's It's a function, takes no arguments, returns a string, it hasn't evaluated there, it will evaluate it only when you are calling it. And this def saying hello, it says only that it returns unit. So if I will go here and say I am calling just saying, right? Because it has no arguments, I don't have to put the, I could call it like this, or I could call it like this, and when I'm calling in, it will evaluate the inside, the body of the function, which is just hello world. And as you can see, it will say result is hello world. And if I would be to call this other one, saying hello, just like that, it will just print this part inside the method. This part is evaluated, but it's never returned. So that is the difference between the equals here and not. It will be just like the void method in Java. So that is one thing. Another big difference between the ones that you define as a, let's say as a val, is that you can do anonymous functions. So anonymous functions, you don't have to give them a name, so you don't have to start with a def. So you say just, I have some parameters, I have an int, and the body of the function will be x plus 1. Of course, you can say here what it returns, but it's not compulsory. And if you do say this, apparently you can't. I just have to see it. Might need to do this. It's not possible. Let's see what error it gives us. Wrong top statement declaration. So once you say what it will return, it doesn't like it anymore. Okay, I'll probably edit this one. So this is like an anonymous function. Why? Because you don't give it a name, the compiler will automatically give it a name. And you can say here, okay, this is the body of my function. You can also have a bigger body, and you can do it like that. You might wonder, okay, so what is the advantage of having this anonymous function? Why is it here? First of all, an anonymous function, if I'm going to run this, you will see that it's actually an object. So it's not a method, a function. An anonymous function is an object that derives from a trait called function1, as you can see here. And it says it's an object, it gets an int, it returns an int, and it's of trait function1. This function1 can be until function 24, because actually maximum you can have 24 parameters. Because it's an object, that means that this variable actually inherits methods from his superclass, from his super trait function1. And one of the most important methods is called an apply method. And actually inside this method, you have the body of your function. So if I would say this is my function, I can give it a value. So this val, if I would call this val, what will I expect to have? Initially you would expect, it will complain that I didn't give it a parameter. but actually it doesn't complain of that because this val actually holds the object of the function. So this function, as you can see, is the function has this value. In order to actually apply the function, so to actually execute this code here, right, inside the code, in the generated class, you will actually have an apply method with one parameter x and then the body. So what you will do is you have to do dot apply, and you will say 2 or 3, and that is your parameter, and then it will do 3 plus 1. So this is how you call this function, and you will see here, yeah, result is 4. And because it's quite tenuous to always say apply, they got some syntactic sugar, so you can just say it like 3, and inside the compiler knows to add the dot and the apply, right? So these two calls, this and this, are equivalent. But remember, whenever you're just gonna call it without the parentheses, you're not calling the apply, so you're not calling the body of a function. You're just calling the variable that holds the object of the function. And that is very important to know on the difference between a def, right, and a val. Is that if I would just call here just saying without apply, it will still evaluate the body, right, because this is a method, but this one here is a function, it's an object, so you have to call the apply method. Another important very important difference between a def and a val regarding functions and methods is that if you do a def, you can give your arguments default value. So, and I'm gonna define a function called multiplication, and I'm gonna say x is int and y is int, and I'm gonna say x times y, and I'm gonna print the arguments. X is and this is how we see what happens now. If I'm gonna say multiplication now, and I'm gonna say 3 and 4, it will print these values, and the result will be 3 times 4, 12. Right? So we say 3, x is 3, y is 4. But let's say by default, if I don't give any parameters, x will have value 2 and y will have value 1. So now, because I gave these default values, I can say just multiplication, or not even bother with calculations. Okay, it gave me an error, and it would say error is missing arguments for method multiplication. Follow this method with underscore if you want to treat it as a partially applied function. So if I put calculated, it won't complain anymore. I think the underscore we're going to talk about it in a future lesson, so I'm not going to go into this now. But this should work, and this should say the default values are these ones. You don't have to give to everything a default value, so you can do it like this, right? And only y will have a default value, and you'll have to say, okay, the first one is a 2, and then it will have y as a second value, which is default. You might wonder where this could be useful for you. For example, when you're gonna define the constructors or methods that take things that are injected for you, right? You will want them to have a default value, which is probably auto-wired or something. But for example, in your test, you would like to use the function with some mocks. So then you will give these values. Otherwise, it will use the defaults. So now that's the best example where we use this one. So as a homework, you could try to play around with these default values and see what you can make of it. Okay, what interesting part, and when you declare a function, just like in Java, we have multiple arguments, varied length arguments. And you know, when you want to apply something and the arguments come from a string of characters somebody's typing, and you don't know exactly how many of those will be, right? And you don't want to make it an array, so they're variables, and you do, let's say, show all, and these are the arguments, and they're all integers, and then you put a star at the end, and that tells it that, okay, it's a variable length thing. And I'm gonna say, I'm gonna loop through the arguments, right? And I'm gonna loop it with for each. I will explain this one later, but for each is just looping through print. And I'm gonna say for each of these arguments do a print line, so it will know automatically how to print this part. And now I'll talk about how this thing works a bit later on, but for now just trust me that this is how you would, this is the important thing, the syntax for the variable length arguments. And let's see this one, how it looks in there. And I'm gonna say show and show. Okay, let's try it. So what this show all said, it actually could not infer anything because I don't return any expression, so it will say init unit. This is the argument, which is a variable list of arguments, and I'm showing all 1, 2, 3, 4, and the second list is 2. Okay. Another interesting thing you can do at the def, also with an anonymous function, I suppose, but is to partially apply it. This is a bit similar to when we gave default values, right? So I'm gonna say multiply, and I have an integer and a second integer, and I'm gonna say x times. Now I know I'm gonna use this multiply function. It can be any function, and I know that in my program, most certainly, let's say the first argument is always going to be the same. The first argument is always going to be 2, and then I'm defining times 2. I can say times 2 is multiply, and I'm saying multiplies 2 always x, and then the second argument is something that I'm going to give. So whenever I'm going to call times 2, I'm going to call it to the 3 times 2 to the 4. These ones are going to be partially applied. So I'm partially applying here this function. I'm pinning down the x with a 2, but this entire function is not yet evaluated, right? But then when I'm going to call it with the second argument, this will be evaluated. This thing has a lot of applications, of course, but we will get into it later on. And the last thing about functions that I wanted to say is curried functions. And let's say that sometimes it makes sense to let people apply one argument now and some other arguments later on, right? And this can be this can get very complicated, but the basis of this currying, it says like this. I'm defining the function and I'm making the argument separate, which you can definitely do, and within separate parentheses. I'm gonna say this returns an int, and what can happen in any case, you can call it like this, and it's the same as declaring it with all 2 second variables together. Or you can say I'm gonna call it, and I'm not gonna make use of the second parameter, and I'm gonna say this is val a right, and then I'm gonna do something here. And after a lot of computation, because maybe at this time I don't know what the second parameter might be, maybe I need to do something depending on what the first parameter will be. You know, I need to do some calculation, I need to go to the database, I need to take it out. So after that I can say a multiplication, and I can apply the other one. Let's see what happened here. As you can see, I partially applied it, and I say a multiplication is actually a function, is the other function that will take only one argument, because this argument has been fixed down, I already know it, and then the other part is a function that takes an int and returns an int. So you'll see a lot of uses of this later on, but now just so you know how it looks like. So this will be the end of the first part, the basics, and we're gonna continue with classes and other nifty things later on. Thank you.